So let's define one function here, right? Define one function. Let me, anyway, we are already imported, we don't need here. So I'm going to define one function. With the help of function, I'm going to do some kind of an operation. So what I will do, I will define one function. Suppose this is a salary hike. There are employees and company wants to increase their salary at some percentage, right? Depending upon their current salary. So that is the requirement. So how much percentage and all we'll discuss. And I will also talk about this. Anyway, this is a simple function only. So I don't need to repeat much, explain much. So I will just quickly go through this. Define salary hike, function name, and this is our argument. And I'm going to pass some data here, right? The employee salary I'm going to pass, and I will check if that employee salary is greater than 3,000. If it is 3,000, so what I'm going to do, I am going to return some amount. What is that amount? The 3,000 plus I am giving him 30% hike. I'm giving him 30% hike. Sorry, 3% hike. Right? So basically, or you can say, let's take only 0.3 here instead of getting into 30% or 3%, depending upon whatever the salary is. So if it is greater than 3,000, I wanted to give some percentage of hike. So I will take this data and multiply with the 0.3. It is going to be some percentage. Right? So that whole data I will be adding to the original salary. 3,000. Suppose it's a 3,000 plus 3,000 into 0.3. So you will, whatever the result you will get, you are going to add to that, right? You will see that how much data it will come back, because here we are not talking about a particular number, because the condition is greater than 3,000. It could be 20,000 also. It could be 1 lakh also. We don't know. So whatever the amount is there, we are going to multiply with the 0.3. So that amount will be added to his base salary. If it is not greater than 3,000, then it will come to else part. There I'm adding, I'm just basically trying to give 50% here, you can say, right? X data, suppose if I take the same example, 3,000, so not 3,000. So yeah, 3,000, because it is because greater than 3,000 means it starts from 3,001, right? So this one say X equal to 3,000. So 3,000 into 1.5. So 4,500, right? So 4,500 will be returned. And what is this np.ceil? np.ceil means basically ceiling. When I say ceiling, if his salary is returned as 4,250.83, I cannot give this salary, right? Either I have to give 4,250 or 4,251. I want the round number, right? So I don't want to give this decimal or the fractions. So yes, so it will convert that into ceiling. One next round number, right? If you have this kind of a number, it will return this rounded number. So that is basically what this function. So you see this, how we can add the percentage salary to the existing salary. A very simple concept here, nothing much complicated. So quickly create a data frame here, right? So this is basically employee salary. So their department is there, and employee number, employee name and salary, right? So their salary and the name. So what I want to do, I wanted to give a new salary. I wanted to tell them their new salary based on the existing salary. What I'm going to do first, I'm going to create a new column here because I wanted to document, right, what was their previous salary and new salary. So for that, I'm creating a one more column, df, and we know how to create a new column, equal to sorry, equal to df salary, select this guy, then I say dot apply, then I'm going to call this function name. This is your function name. We just discussed the function name. So what happens here? So this is what it happens. Whenever I say dot apply, it will take this salary. It will take this salary, first one, let's say Rajesh salary, and that salary will be, because I'm calling this function, right? So here we have a function. Let me show you that. So here we have a function. Here we have a function, and it needs one set of data. So it will take Rajesh salary and will pass it. So x equal to 4,944. So is 4,944 greater than 3,000? Yes. Then that x data will be passed here, and this calculation will take place. And it will return the new salary. This will return the new salary. That new salary will be placed under this column. Under this column, exactly right beside this guy. New salary is data. And next time it will pick Shankar salary. Shankar salary now x equal to 5,455. So according to that condition, it will add some percentage of hike, and the new salary will be inserted here. Similarly for Sindhu, Akshay, Vivan, Monica, and all those guys. So that is what this dot apply does. One by one, it will pass the salary data, and it will fetch the new salary. So whole salary, new salary data will be stored in the new column, that is new salary. So let's execute this. Salary is not defined. I did not execute this. Sorry about that. Let me execute this. Now I'm going to run this. Now you can see that this is his old salary, and new salary is going to be 6,428. Right? So how easy it is to increase employee salary, even though you have millions of employees, so it is rare. Tens and thousands of employees in any company. So you just need to change your conditions based on how much you want to increase the salary. Can you believe that in simple 4 lines of code, lakhs together employee salary will be calculated? Very simple concept. You can change this condition according to your need. You can add more conditions according to the requirement. How much salary you want to increase, based on what, different conditions also you can add. Maybe you can check the department also if you want. So this you can play around like however you want. We have solved some kind of a medium to complex problems using functions, so that knowledge you can bring in here and try to manipulate. Right? So that is basically what I'm trying to do here. So old salary and new salary. Everything is ready in just 5 to 10 minutes of code. All right. Fine. Now that is one way of adding a data. So with respect to salary, we have used some function. Now suppose I want to create one more column and let's try to do some more activities here. Now I wanted to create one more column, name length, name underscore length. What is this name length? So I wanted to check how long is the name, basically the characters, length of the name. We know what is LEN. Length is one of the function. What it does, it will just try to count the number of characters. The same copy code, whatever I have written here, same thing I'm trying to do, but this time I'm taking a employee name. Employee name dot apply what? Length function. So what happens? It will take this guy first and check the number of characters 1, 2, 3, 4, 5, 6. Yes, 6. Then about Shankar 1, 2, 3, 4, 5, 6, 7. 7 characters. Sindhu 1, 2, 3, 4, 5, 6. 6 characters. Same thing goes for all these guys. Right? So here we are trying to learn different logics, different ideas, that how we can make use of the functions, our Python concepts, how to fill the data based on different requirements. So let's run it. So now you can see the length of the names, all the names. So this is your new data. So anyway, here it doesn't make any sense. So why do we need to calculate the name, length of the name, right? Yes, I agree that it doesn't make any sense, but we are trying to learn new ideas, new logics, how we can use them. That is the whole idea here, right? So we'll try to understand a lambda function again, how we can bring in lambda function, right? So new salary dot apply. So earlier what we used a normal function, right? So this time we are using lambda function. This time using lambda function. What we are trying to do here? We are trying to apply some square root, right? So let's execute this. So let's interpret. What is our new salary? So whenever I say df new salary, I will fetch this. So then I say dot apply. So first time 6428 will be passed here. So for that 6428, I will take a square root. And this is the square root. Next time this guy and will be passed here and take a square root. This is the square root. Similarly, I can take a square root of all. So using the lambda function also we can work. Right? Now suppose say that this is our new salary. Where is that new salary? That guy, that guy. Your new salary. So now company wants to know that how much salary we are giving to our employees. Total salary we are giving to our employees. Suppose say there are 900 or 1000 employees, 9000 employees, or whatever number of employees. So we have increased their salaries. Now company wants to know how much we are paying as a salary, right? So they don't need to do much of a calculation. What they can use, they can select their column names, whichever columns. So in this case, new salary, and I will say dot sum. So it will tell that yes, you are paying $69,915 to all the employees. Means all employee salaries collectively, it is coming up to close to $70,000. In simple line of code, I will be able to find it using dot sum. Select your column name. And yes, obviously you have to give your data frame and column name. And the column name should be always in the square bracket. Don't forget that. And in the quotes. Right? Now, if you want to find out the minimum salary you are paying and the maximum salary you are paying. Concept is very simple. Instead of a sum, what I will do, I will write minimum dot maximum, whichever the salary you want to identify or wanted to know, minimum or maximum. Yes, this is for the minimum. You can print both in the same line, not a problem. Just you have to separate with this comma and df salary dot maximum salary. It will give both minimum and maximum. You can write in different lines as well. So here I am writing in the same line. This is the minimum salary. This is the maximum salary you are paying to one of your employee. Right? Simple functions here. Now, suppose there are columns which are basically too many columns. Right? Here we know that okay, department, employee name, salary, 4 or 5 columns we have. Suppose any data sets having too many columns, and you wanted to know only the column names. You wanted to know only the column names. You don't want to see the data and all. Right? You wanted to extract only column names. For that, we already have this columns, your data frame dot columns. Data frame dot columns, it will just give you the number of, the column names. So here we have department, employee name, salary, new salary, name underscore level. So these are all the column names in this particular data frame. Right? Just I want to know that what and all data we are storing, right? Someone definitely wanted to know. Are we storing their personal details? Are we storing their our privacy things like a phone number, date of birth, email ID, things like that. So if we are storing it, so definitely that column name will be there, right? So yeah, for some one or other reason, somebody wants to know what are all the data we are storing. So we can always pull up this column names, right? Fine. That is how we can fetch the columns of any data frame. Just say dot columns. So you want to store that columns in one of the list. So just use this and convert that into list. That's all. You wanted to store. Here what we are trying to do, we are not storing, right? We are just printing and just checking it. But if you want to store it, yes, define one variable and just get the column list. And you can print that here. Right? So these are all the column names. Just directly we have printed, but here we have stored in one variable and trying to see that variable data. Fine, that's about creating a column, adding rows, using different logics, different ways of adding data or inserting a data into any particular column. Suppose I want to delete one column. See, now we have updated the salary column, right? So this is our new salary. So now we don't require old salary data. Why should I store it? Right? Maybe name length. So maybe somebody thought that, okay, why are you doing this? It is not necessary. Right? So in that case, how do I delete that column? So just use del, D-E-L, delete. Okay, which column? In this data frame, delete the salary column. That's all. Right? So yes, I will delete and print the data frame. So the salary column gone. Now employees will have new salary. If you want to delete this, just change it. If you want to delete department, you just change the names. That's all. Right? Fine. Now that is a simple operation. Now again, if you want to see or if you want to sort the employee details, like I wanted to see the highest, anyway we have that dot max function that we can use to find the maximum salary. But if you want to sort the data based on the salary, right? So sorting is also one of the important concept in anywhere, either in a programming or anywhere. So definitely the sorting thing will be there. Similarly, in pandas also we have. So here we are going to write your data frame dot sort underscore values underscore values. So when you are sorting, obviously question is that there are 1, 2, 3, 4 columns on which column you wanted to sort the data frame. So I'm going to pick salary by equal to, here your column name will come, column name, by this column name. So here I'm choosing new salary, right? So let's print this. So by default, it will show you from lowest to highest, that is ascending order. If you want to bring the highest salary first, you just need to make that ascending equal to false. Right? So here, if I don't give anything, it is ascending equal to true by default. So if I want to change it, just make it false. So how to check again? The default value, keep your cursor and press shift tab, and where is that ascending? Yeah, ascending equal to true. Right? So I'm trying to override and changing it to false. So when I say false, yes, obviously your data will be sorted in the descending order. So highest salary first and the lowest salary last. So you can play around with this particular parameter. All right. So earlier we have seen this sorting using just a dot sort something, but here we are writing sort underscore values. All right. Now let's understand this part. So this is, let me print this. Okay, so it looks big. I'm sure it looks confusing and so many data and things like that. But end of it, this is a simple data frame, right? Data frame. So name, gender, and things like that. The reason why are we discussing this data frame, and lots of NANs are there, right? We discussed what is .NAN, so I don't want to repeat here. So in the name we have Ramesh, Raghav, and 2 names are missing. Similarly, gender is missing. Phone number, some numbers are missing, right? So wherever it is missing, we have replaced with a NAN using .np.nan. So now, earlier we have seen that using 2 columns or 3 columns, how many null values are there and all. So we can easily count them. Okay, column A, 2 data missing. In the second column, 1 data is missing. We can easily figure it out just by looking into the data frame. Suppose say that you have say hundreds of columns. Even if you take this one, here we have 4 plus 8, around 11 columns, right? So if I ask you that how many null values are there, and in each column, so I will start counting. Okay, in the name 1, 2, in the gender 1, in the section no, in the class 1, 2. So likewise, you will start counting. Suppose say there are, instead of 4 rows, suppose say there are 1000 rows. Then what you are going to do? It is difficult to count, right? How many data missing? Somebody, your boss is asking that, or in that big bazaar, whatever the example I gave earlier, the boss is asking, did we get phone numbers of the members who are trying to enroll? There are 10,000 students, customers have dropped their details, and out of 10,000, how many did not give the phone number? Right? It is difficult to check each and everything, right? So rather what I will do, I will try to use some logic here. write some simple code to find the count of missing values and for each column. In each column, how many data missing. So for that, what I'm going to do, I am going to write data frame dot is null dot sum dot sum. So this is going to give me the counts of missing values in each and every column. Now, if you look into this, in the name column, we have 2 rows missing, right? 1, 2. In 2 rows, we have missing some data in the name column. Similarly, in the gender, 1 data is missing. In the section, so yes, there is no NAN. Similarly, for the class 2, same thing goes for all the columns. So it will count and give you the result with respect to each and every column in your data frame using a simple function, simple data frame methods here, right?